In this video, we're going to continue topic 10.13, and we were looking at example 4b. In this one, we have to take the derivative of the function and then find the interval of convergence. So I rewrote my function off to the left here. I'm going to take its derivative, which we're still going to have this little series, sum equals at 1 to infinity out front. And then I know when I take a derivative, I have to bring my exponent to the front. And then I subtract 1 off my exponent. And then we have this n. So these are going to cancel. So this is really equal to the sum as n equals 1 to infinity of x to the n minus 1. We're going to put that into our ratio test to find the interval. So we're going to say the limit as n approaches infinity of, and I'm going to do plus 1 in for the n. So n plus 1 minus 1 over the original, which is just n minus 1. And let's see what happens there. It looks like these guys are going to cancel, and I'm going to have the limit as n approaches infinity of x to the n over over x to the n minus 1. All right, so if I take this apart a little bit, I have the limit as n approaches infinity of x to the n over x to the n times x to the negative 1. Well, the x to the n's would cancel, and then this guy would come upstairs because we don't like negative exponents wherever they're at. So limit as n approaches infinity of the absolute value of x. Well, there's nowhere for me to put my n into, so I know that my limit has got to be equal to the absolute value of x. We're going to force that to be less than 1. So my interval is going to be between negative 1 and 1. So my interval didn't change. I just need to change look at the endpoints now. So I am going to substitute in negative 1 into my original series here. So we're substituting into this. So for x equal to negative 1, we would end up with the sum as n equals 1 to infinity of x to the negative 1 minus 1, which is the same as saying x to the negative 2, which is the same as saying 1 over x squared, which we would recognize as, I am not plugging in. All right, I caught myself making a mistake. So I plugged into the n instead of the x. So hopefully you caught that. So we really should have negative 1 to the n minus 1, which if I use the nth term test on it, so I'm going to use nth term, we're going to look at the limit as n approaches infinity of negative 1 to the n minus 1. And if I plug infinity in there, I end up with that it is equal to probably negative 1. It doesn't really matter. It's either plus or minus 1, but it's definitely not going to be equal to 0. So therefore it diverges by nth term. So that means I'm going to keep the no equal sign on my interval. All right, let's take a look at if I substitute in 1. I'm just going to put my work off here, off to the side here. So if x is equal to 1, we're going to plug into the x instead of the n this time. So n equals 1 to infinity of 1 to the n minus 1. So we're going to use the nth term test again. So I have the limit as n approaches infinity of 1 to the n minus 1. And when I plug in infinity, I really get the same thing. I'm getting 1 to the infinity, which is definitely not equal to 0. And so I know that it diverges by nth term. And so this is just a less than. And you'll notice that on our endpoints on the other one of them was equal to. So it did, in fact, by changing, taking the derivative, it did change how it was convergent on my interval.